Hey guys, thanks for tuning into CMTEQ channel. This is a follow-up tutorial on the previous one on the series of Arduino and Raspberry Pi interfacing. So last tutorial, as you can see right now, we have a bi-directional communication in a way that we configured our Arduino to do some light measurement. However, we do not have a light measurement software, or we do not have a sensor attached into our Arduino. So we basically just calling a random function and generating some random value, assuming that the random values are basically the light level. And from that, we then send it to the Raspberry Pi. Then the Python is going to collect the data via the serial interfacing. And from there, the Python script will be able to decide what to do with the data. So here we are basically just saying, okay, if the light level, right, the value generated by the random functions, if they go below 100 lux, which is a light level, then we would like to turn on the light. And if they go above 300, then we turn off the light. So as a result, you can see we have the random function that is busy generating this data. Okay, and you can see the LED going on and off as per the instructions from the Raspberry Pi to the LED attached on the Arduino board. So basically, briefly, that's what we did the previous time. So if you are catching up right now in the middle, you're catching a snake in the middle, it will be good for you to go watch the previous tutorial. So in this tutorial, this is going to be very quick. I'm basically going to replace the random function here that we're generating random value with an actual sensor that is going to measure the light for us. So this will be just a basic, simple photo transistor that I am going to use, as you can see there. So I'm going to use the photo transistor to read the light level, and that information will then be fed into the Arduino's analog pin. Then that will then be sent into the Raspberry Pi. So this is just going to be a dummy light level reading, not a very accurate representation, but for what we're trying to demonstrate here, it will give us an idea of the kind of application we were talking about. Then just having a random function here generating the values for us. We will actually use a light sensor to do the deed for us. So without any further ado, if you find this tutorial useful, please give it a thumbs up and subscribe to CMTEQ channel so you can be assured to get more tutorial of this nature. So to start off, I'm going to configure my Arduino analog pin 0 so that I can connect the light sensor, the photo transistor, onto the analog pin. So I'm going to declare or define a pin, and then I'm going to call it photo transistor, right? So these will be connected on pin A0, hopefully photo trans. Then I'm going to come here. Basically, I just need to set the pin to be an input, right? Because it's going to receive input data. So I'm gonna say photo trans, and that will be an input. Right now, the next thing to do here is basically to come here and modify this function. So to do that, I'm basically going to copy this line of code, right, paste it here. Then we're going to comment out the random function generator, and I'm then going to replace the random function with a simple analog read. So we're gonna say analog read. So what are we reading? We're reading the photo transistor pin. So we're reading the photo transistor that is attached to pin A0, right? So right now I can basically just upload this code onto the other side. Okay, we do have an error. What is going on? Okay, we need to stop this code first because that's happened when we were trying to upload. So the Python serial communication must be closed. Okay, there is still a problem here. Okay, the serial port, we lost the serial port in the process, so let's just connect it again. There we go, we are uploading. Cool. Now we are on standby. Okay, so that is the extra line of code I added there. Now we can start this Python script and see if we are able to do some measurement. Okay, now obviously we can't do measurement right now because the phototransistor is not connected yet, right? So the phototransistor is not connected and we are measuring 0 light level, and the LEDs is indeed on. The street light is on because we are measuring 0 light level. Right, so as I have already indicated that the phototransistor here will be connected into the analog pin 0 here, okay, so that we can get these measurement going on. Now this Arduino add-on board here got this little circuit here that is going to interface these phototransistors, so you cannot just plug it there and then expect it to work. So there is a way in which you have to connect it. So before I can plug it in, this is the circuit that is sitting right there. So we basically have, so I'm just going to make a high level representation here. So we assume that this is A0, the analog pin. So the analog pin, so this Arduino A0 pin is connected to an external phototransistor circuit. So I'm going to just draw a dummy phototransistor circuit that will look like this, right? So here is where we've got the external light falling on the phototransistor. So we all know the principle of operation here is that we're going to have a 5 volt here, right? So you'll have a 5 volt. So depending on the amount of light falling on here, so the resistor between the collector and the emitter, so this is a resistor here, RCE, okay? So this RCE will become smaller and smaller as more light falls into the base here. So it basically base biasing with the light, okay? Then here we're going to have a resistor, okay? So we're going to have a resistor that is going to be connected to ground. So this pin A0 is then connected here to read the voltage drop across the resistor. So assuming that you select a small resistor value, let's say 2 kilo ohm, okay? So you select a 2 kilo ohm of resistor value, and depending on the type of phototransistor you choose, they're going to be a very big resistor across RCE here. So depending on which transistor you select, you're going to have a large resistor between the collector and the emitter. Now, so as the light falls, then that resistor is going to decrease, setting up a current here. So i.e. the emitter current. So that emitter current will then flow here and then cause a voltage drop across its resistor. So that is the voltage that you are reading here. So now you are doing an analog read with that voltage. So you do analog read with that voltage, okay? So now the ADC can give you a reading based on the resolution of the Arduino ADC here, which is 8-bit. So this is basically the working principle of the circuit that I have here, where I'm going to connect this phototransistor. So I'm just going to connect it now. So basically, as you can see here, so the long pin is the positive pin, okay? So that is my anode, and my anode is going to be connected to the red wire, which is going to be connected to the 5 volt, okay? And then the emitter that will then be connected to the analog pin 0 that is connected with another resistor there. So I will plug this way. Now that the phototransistor is connected, I'm going to just stop the Python script here. Then we need to reset the circuit. Alright, so let's go ahead and run the Python script again and see what's going to happen. So Arduino connected, we're not getting any measurement. Okay, let's try to saturate with the cell phone torch here. So I'm going to saturate the phototransistor, right? So I'm going to saturate it and see if we're going to get, okay, so as I saturate it, you can see I'm getting some reading that is very high, okay? And on the LCD there, we can see that the LED is indeed off, and that is precisely because we configured it that when the light level goes above 300, the light or the street light should be turned off, and that's exactly what happened. So if I put the torch away, the light measurement is going to drop. So the light measurement is supposed to drop, but it seems like because I'm recording here, there is just too much light here for it to go below 100 lux. So if I try to cover it with my hand, okay, so we're still not getting any reading. Okay, so I think what I'm going to do here, I'm going to map it, the analog read. As you guys have seen here, we were able to go up to 10, 11, the maximum, almost a maximum ADC value there. So what I'm going to do is I'm going to stop it and just try to map this function here, so that we can basically almost what we were getting with the random function generator. So we're going to squeeze it in between sort of these parameters here. So I'm going to come here. Basically, we wrap everything into the map function. Right, so this is what we're going to map. Okay. Right, okay, so that's what we are going to map there. So from 0, 10, 23, which is a maximum ADC, then we want to map it to 10 and 350, so that we can stay within this range here. Now let me just upload it and see what's going to happen. There is no clash. Okay, everything is fine. Now let's try to run this again one more time, the Python script, and see what we will be getting. Okay, now you can see we're getting a light level that is 82. So this is basically the lowest we can get here, 83, 84. Okay, and the light is on because it is below the 100 lux. Now if I bring on my cell phone torch again here, so that we can saturate the phototransistor, because by saturating the phototransistor, we basically going to push it to go to around 350. So as I get closer here, just bring him closer, you can see the value is increasing there until we're going to reach saturation, and we are approaching. Okay, there we go. Now you can see that it is saturated, so the phototransistor is saturated, and we're getting a reading of above 300 as per our mapping function. Right, but now when I remove, and it drops again and the lights come off. So basically it is indeed working. Okay, so this is a street light function. So when the lux level goes above 100, so this is now above 300, so this is now simulating a sunrise and so forth. And when it goes below 100, the street light comes on. Okay, so this is indeed working, and this indeed demonstrates a real life application of a street light system. So this is basically what I wanted to do as the second part of this tutorial. So if you like it, please give it a thumbs up and subscribe to CMTEQ channel. And once again, stay tuned for more tutorial on Raspberry Pi and Arduino. So this is just a beginning. There will be very complex system that we're going to do with the Raspberry Pi and Arduino. Until next time, cheers.